Surface area, prisms, and cylinders. What I want to do is start with a general statement. We do not have any formulas for calculating the surface area of polyhedra. That would mean prisms, pyramids, platonic solids, and anything else that fits the definition of a polyhedron. However, we do have formulas for the shapes that are not polyhedra, such as cylinders, cones, and spheres. Okay, generally speaking, for the shapes that are polyhedra, what we're going to do is break them apart into all of their faces, calculate the individual areas, and then add them together. Okay, again, we do not have a formula for this. Our approach to calculating the surface area is going to literally be breaking them apart. Before we start any calculations, we're going to get through a little bit of vocabulary. A prism is a polyhedron with two congruent faces called bases. For example, this picture here. The bases would be the hexagons that we have on the top and the bottom. Those bases will lie parallel to each other. The other faces are called the lateral faces. In this figure, they would all be rectangles that we have here. Okay, when we end up talking about pyramids, the lateral faces will be triangles. The surface area, which is generally thought as the total surface area of a polyhedron, is the sum of the areas of all the faces. Okay, so the surface area here is going to be the area of the two hexagons and the 6 rectangles that we have. The lateral surface area. The lateral surface area is the sum of the areas of the lateral faces. So that would be all the surface area minus the bases that we have. For example 1, we're going to find the surface area of a rectangular prism. What we have first is a picture of the rectangular prism as it would exist. We do have all the dimensions. We have a width of 5, we have a depth of 6, and we have a height of 2. The other pictures are going to demonstrate how we could imagine breaking this figure apart and laying it flat. This would be a picture of it partially opened, and this would be a picture of it laying completely flat. And whether we lay it out flat or we look at it in its original form, we should be able to figure out that this thing is completely made out of rectangles. In fact, it has 3 pairs of congruent rectangles. Okay, on the top you've got a 5 by 6, which we see here. We also have a 5 by 6, which is there. So you get a pair of congruent sides there. The front, which is a 5 by 2, you have here, and then you've also got it in the back. For the left and the right, you've got a 6 by 2, which we see here and there. So once we have an idea of all the pieces that we have, what we're going to do is just devise a way that we can add all their areas together. Okay, what I'm going to do is look at it as having 3 pairs of congruent sides. Okay, I got the bottom and the top, so I've got 2 5 by 6s. The front and the back are going to be the 5 by 2. So I have 2 of those. And I've got 2 sides that would be 2 by 6, which would be the left and the right. Okay, so all put together, this would represent the total surface area. Okay, so we got 30 times 2, which is 60. We've got 10 times 2, which is 20. We've got 2 times 12, which is going to be 24. So the total surface area is going to be equal to 104 centimeters squared. Example 2, the total surface area of the triangular prism is 84 centimeters squared. What we are asked to do here is to find the height. Okay, so notice in the figure, we don't actually have a height here. That is an unknown value. Let's go ahead and just call that x, just for the sake of having something there. Okay, like the previous example, what I'm going to do is try and imagine this broken into all of its pieces. It's going to have the 2 triangular bases. It's also going to have 3 rectangles that go around it, which would be the lateral surface area. Okay, so the 84 centimeters squared has to be equal to the sum of the 2 right triangles plus the 3 rectangles that we have, which, if you imagine breaking this apart, like unwrapping it in a way, you could actually look at those 3 rectangles as one big rectangle, just divided into 3 parts like that. Okay, so information that we do have. From the triangles, these happen to be right triangles, so the base and the height can be the 3 and the 4. Okay, with respect to the lateral surface area, the big rectangle that I have here, the dimensions that would go across the top would be a 3, a 4, and then we don't know this one. However, this is a right triangle. We do have a 3 by 4 as the leg lengths, which means that this is a triple with a hypotenuse of 5. So that would actually be a 5 there. And altogether, the 3, 4, and 5 is going to make a 12, which would be multiplied by the height x. Okay, so the height that we're looking for, x, is now just a variable within an equation. What we'll do is go ahead and simplify what we got, then solve for that x. Okay, so 84 is going to be equal to, these will cancel. That gives you a 12 plus 12x. We can subtract the 12. 72 is equal to 12x. Divide by 12, and x is going to be equal to 6. That would be 6 centimeters. As mentioned at the beginning, solids such as cylinders, cones, and spheres do have formulas for calculating the surface area. A cylinder is a solid with congruent circular bases. It's a lot like the idea of a prism, except that your bases are going to be circles, which means that your lateral surface area is more of like a wrapping that goes around it, but is not broken into a bunch of rectangles. The pictures that we have here are going to indicate how we separate the figure into all of its parts. So we start with a general picture of a cylinder. It does have a radius of r and a height of h. Those will be the two variables that we're allowed to use when we calculate our surface area. Those are really the only dimensions that a cylinder has. You do see here 2 pi r, and you should recall that 2 pi r stands for the circumference. So that part's going to show up in just a moment. Okay, in the second picture, what we can imagine is that we cut that lateral side here so that we can open it up, and as we open it up, it becomes a rectangle. Okay, so you got your circle bases, and then you've got a big rectangle. The areas of the circle bases are each calculated using pi r squared. So you actually have 2 of those. So overall, the surface area here is going to be equal to 2 pi r squareds plus the big rectangle that we have in the middle. Okay, as far as the rectangle in the middle, the dimensions, you do have the height. The wrapping direction here is actually the circumference because it has to go all the way around the circular base. Okay, so for the rectangle part, it would be 2 pi r, the circumference, multiplied by the height h. And that would be a formula that you can use for all cylinders, something that we couldn't do for the prisms. Example 3, you are using a cylindrical stencil roller to paint. What area will be painted with 1 rotation? Okay, in other words, we're going to take this roller, we're going to roll it once. Okay, wherever it starts, we're going to roll back to that same point, and we're asked how much area is going to be painted with that. What that really refers to here is the lateral surface area. Okay, so the bases of the cylinder don't really matter because they don't contribute to the painting. It's just going to be that wrapping or that lateral surface area that we have here. All right, so if we go back to the formula, that would be the formula for total surface area. We don't need this part. That doesn't contribute at all to this problem. We're just asked to figure out what that would be. Okay, so lateral area is going to be equal to 2 pi RH. The radius is actually going to be half of the 2.5 inches. That is going to refer to the diameter here. Okay, so the radius is half of 2.5, which is 1.25. The height is the length of the roller that we have here, which is 6. And if we calculate that, we'll answer the question. To do this, I could just type the whole thing into the calculator, which is perfectly fine, but I want to show you a little bit of just the mental math that we could do. 2 times 1.25 is actually just going to get you back to the diameter, which was the 2.5. So we've got 2.5 times pi times 6. 2.5 times 6 is going to be 15. So this is 15 pi. Of course, if you leave it in terms of pi, it doesn't give you a great answer, so we'll go ahead and multiply that using the calculator. 15 times pi is going to give us 47 point, let's just call it 1. Okay, so we're going to get 47.1. This would be inches squared.
Later, blah.